Okay, so we were talking about when is serial better, and we kind of put the statement out there that when we need to limit the number of errors or um, limit the variance of a connection, serial might be better. What do I mean by limit the variance? So we were talking about parallel being bursty, so lots of ups and downs and things like that. So variance would be kind of limit the variance would be the opposite of that, right? We want it to be as even keel as possible. So can you think of any examples based on your own experience with technology where having a consistent data rate when we're transferring data might be preferable over a maximum speed data rate? Okay. Actually, not what I had in mind, but a perfect example. I mean, that's well, I don't want to give you too much credit.
Assuming your average connection speed is equal to or greater than the
so the real issue with streaming. The short answer, you're right. Streaming is a good example for this. It's not the example I was thinking of. We'll kind of get back to that in a second. But where streaming really fails is when your connection is extremely bursty. So where you initially start downloading and it thinks it only needs to buffer this amount in order to keep it going, but then all of a sudden your connection speed drops way off, and you run up to the buffer, then you just can't keep up again. Well, yeah, when you have just inconsistent speeds. But in general circumstances, I mean, I think most people with their home-based internet, the variance in their internet speed isn't ridiculous. You don't have these huge peaks and valleys. You have, more like that type thing. So typically, you'll have Netflix will buffer on the conservative side, so it might take 15 seconds for it to buffer, 20 seconds to buffer on a slower internet connection, but then you're probably going to be good unless there's a weird hiccup in your internet. I would say, generally speaking, home-based internet with Netflix is pretty reliable. But certainly, I think the school-based internet would be a good example. And it's not so much that our internet here is bad; it's that they're serving a lot. They're serving more people with more limited bandwidth. So, I mean, Time Warner Cable is selling, is sharing more bandwidth than the university has to all of its customers. Yet the number of people who are using the internet here on campus is a higher, probably a higher population density than Time Warner for the same amount of bandwidth. So you have more people vying for the bandwidth. You also have that bandwidth being earmarked for different things. So with Time Warner, they're selling you internet for kind of a general purpose internet solution. So your upload speed is slower than your download speed because your upload speed is just being used for requesting, give me the results of this Google search. That's the request, and then you actually get a whole bunch of data as your response to that. So your download has to be faster. But the idea here is here on campus we have a whole bunch of other things that get in the way. We segregate our various dorms and stuff like that, so they're sitting behind switches and firewalls. Then you have the university itself, which is often under a DDoS attack. So a lot of things are happening that kind of change the dynamics of a enterprise level network like we have here on campus, which then leads to there being a lot of variance in the connection. So what you're saying is here on campus, streaming Netflix is I guess I know this because I have a big screen TV in my office and I stream Netflix in there, and it is hit and miss. It'll be
sometimes perfect.
Yeah,
other times
I'll be good for 2 hours, and then all of a sudden I can't even get a movie to play.
It's just buffering, and then
yeah, it just says error, can't play.
That too.
Yeah, so
you start buffering, and then you play for about 5 minutes.
Yeah.
What really happens is when you start watching movies that just don't happen to be quite ethical. And
well, not on Netflix.
Netflix.
So Netflix is better on average. Yeah. So, but I mean, if you're experimenting with data protocols for downloading large files in video format. The you're so you're doing like torrent streams as opposed to grabbing the yeah. I mean, I could see that being a problem. So you might as well just grab the. Although downloading the file what takes anywhere between 10 minutes and up to a week. Is that it's kind of like Chicago traffic, same thing. Okay, so streaming obviously is a variance example. So give me a different variance example. Kind of put your mind back in, back a couple of years. So let's say we're in 2008. It's a decent retro time period to go to for what we're talking about here. What's an example of some sort of a computing problem where we want to limit variance? And I mean, it's still the same now. I mean, this statement is true today. How many of you have ever done any video editing or anything like that? Okay, well, 1.5 of you. All right, so when you are working with, one of the video editing software, sometimes they'll refer to something as a scratch disk, right? So what's the scratch disk? When you set up the scratch disk for editing, it's a kind of a large chunk of hard drive that it's using to, for lack of a better word, really buffer video as it's processing, right? As it's compressing the video and all that stuff. Now, video compression is a math formula, right? I mean, they're applying something to it. And if you have a irregular data stream coming to it, I mean, you're compressing data as it becomes available. And you want to keep that data stream as consistent as possible. Now, today we've introduced some buffering things where we kind of buffer it multiple times so that we've kind of guaranteed a consistent level. But before we had that, we were kind of reliant on the consistency, what kind of consistency our data communication channel was giving us. So you might have these great peaks and valleys if you were bringing stuff in over a parallel connection. So historically, for instance, external USB hard drives were considered poor choices for a scratch disk. What was the better choice for an external drive? What was the competitor with USB? You can still get them today, but they're less prevalent today. But so if we go back, let's say 3 years ago, if you went into Best Buy and you were buying an external hard drive, you could buy let's just say it's a 1 terabyte drive. They would have 3 different 1 terabyte drives at 3 different price points. But they're all from Western Digital. They're all the same internal hard drive. What was the difference between those 3 different external drives? Like in terms of the disk speed? Disk speed was the same. All of them were 7,200 RPM. The same physical internal hard drive. But the external USB device was a different price. About $30 jumps per. It was the number of interfaces it had. So today we've been kind of talking about interfaces. PCI Express, serial ATA, all these different things. The interfaces that the most expensive one had was USB, eSATA, external serial ATA, which is just normal serial ATA, you just happen to have a port outside of your computer for it. And then, what was the last one? It was a competitor with USB for a long time. It was Apple's USB. Firewire. Yep, Firewire. So, the go-to move for an external disk for video editing was an external Firewire drive. All right, so this kind of comes full circle back to what we were already talking about. USB and Firewire are examples of these guys. Which is which? Is USB parallel or serial?
Serial.
One would think,
USB's parallel.
but hasn't the evidence of what we've talked about for the last hour maybe, especially our punchline we just talked about, indicate that USB, since it was a poor choice for consistent data, that USB likely is, it's not serial. It's parallel technology. USB is a bursty technology. And we see it even with our peripherals. Remember our good buddy old Alex told us about printer cables earlier? And we went and looked up printer cables and we saw a parallel cable, right? If you go and buy a printer today, what's the cable look like? USB cable. So USB is a parallel technology. Firewire is a serial technology. So Firewire would give us a lower variance connection. It's more of a consistent speed connection. USB would give us a more volatile connection. For a long time, these guys were direct competitors, and it was for a while, Firewire was much faster than USB. Then they were kind of close. So Firewire 2, well, no. So USB 2 was faster than Firewire. Firewire 2 was faster than USB 2, but only sometimes. That's where the competition really existed. Because the maximum speed of USB 2 was faster than Firewire 2's maximum speed. But the consistency was close enough where Firewire 2 was a good solution for consistency. But then USB 3 kind of blew it. That's where the competition ended. That's why Firewire is not a thing. You know, like devices don't come with Firewire ports anymore. that ship has sailed. Is what's happened. But in the early days, it was do you know what the speed of the first USB ports were? And it was shared. It was the maximum bandwidth of a single USB port. It shares its maximum speed with the maximum bandwidth of an 802.11b wireless network. For those of you wanting to flex your computer science prowess. Go into the Google. I only get to Google pictures of stuff. I got video cards. 1.5 megabit for original USB.
12. That's for low speed. High speed was 12.
Yeah, USB 1 was 12 must have been a theoretical max. USB 1 was considered 11 megabit per second shared. Same thing as 802.11b, kind of slow version 1 Wi-Fi. But it's a shared technology. USB 2 maxed out at 400 megabits per second. USB 3 goes way higher than that. But things start getting more inconsistent, but this kind of is another pattern that we've been talking about all night, where there was a competition where one was a little bit faster than the other one. There was closeness in that, but the technologies were different enough that they could be applied to different problems. So, for example, Firewire was a pretty good choice for a scratch disk for a long time because it was fast enough to keep up, right? was fast enough to keep up, but it was also consistent where you wouldn't introduce variance into your video compression. So you hopefully wouldn't have little skips in your video because it was compressed at an inconsistent rate, something like that. Well, then USB got so much faster than Firewire could go that it wasn't even a thing anymore, right? And that's when they just decided they ultimately really slowed it down for video compression. They just said, okay, well, we know it's going to hit this minimum speed. This is as slow as it's going to go. So why don't we go ahead and let's just drop it to that and keep it consistent at that, and we'll buffer in front of that. So we know we'll just keep it coming to the compression algorithm at that constant bit rate. So we'll compress it at a consistent rate. Then you don't have the weird little glitches in the video and that kind of stuff. So USB ended up being a good choice for that. Serial ATA is even a better choice. So serial ATA is, faster than USB 3, and you still have those buffers in place. You might as well just use whatever's the fastest, right? Because now we're not reliant on hope that it's a consistent bit rate. Now we're like, look, we got buffers. We're fine. Send the data in. When this buffer fills up, we'll start feeding this guy. When it's not filled, we're going to stop. We won't feed it. So we've kind of fixed that problem, if you will.
Every time I do something with hope now, we put a little flat piece and a flag to give you hope. With,
the golf from what's his name? Robin Williams. That's right. It's a good skit. The Invention of Golf by Robin Williams. Yeah, probably watch it on your own. It's not a Christian University in class in class type material, but it is quite humorous. Okay, so that's parallel versus serial. So again, we have all these different levels of this competition over the years, and they all are dealing with the same thing. They're all dealing with how do we send data from point A to point B, okay? And then how do we measure the performance of that data? So kind of a topic we've been talking about quite a bit today, and I'm going to actually go back and I want to rehash it a little bit, is this idea of what does fast mean? Or we can replace this and says, what does good mean? When somebody asks you, do you have good internet? What do you say? Well, he says, I don't know. Say, I think I have internet. Maybe. Yeah, but what is it? When somebody asks you if you have good internet, how do you answer that?
Most people would probably answer it like they don't have issues with it, that it's consistent enough that they don't notice that there's a problem at all, regardless of speed.
They don't notice if it's a problem.
Like,
okay.
They're regardless of speed, they're content with what they're getting, and they're not having issues with it.
Okay, fair enough. So that's your layman consumer, right? All right. So, but now we're not layman consumers. We are masters of computer science students, right?
We're not like the steerage.
Well, I mean, you're not supposed to be. You just play one on TV, right? So, we are supposed to know better in here, right? All right, so now, if somebody were to ask you, so we're going to do our classroom participation thing now. All right, do you have good internet? What's your answer? You say yes. Okay. You have good internet, old Alex? You think so. That's not very confident. Is it good internet? Yes or no? Yes. All right. What about you? Good. Crap internet. Bad internet. Okay. Everybody be prepared to defend your answer. All right. Good internet? All right. Are we talking your internet at home or here on campus? Okay. All right. So pick one to defend. So which one are we talking? Oh, okay. Good internet? All right. You on campus or off? Off campus. Okay. So bad internet. Okay. So we'll start here. You said you have good internet. Why is your internet good? defend that?
It's fast enough for my needs and it's consistent.
Oh man, we learned nothing. Tell me about fast enough for your needs. What does that mean?
It means that I have a connection that's, again, using the word fast, that's fast enough that I can do all the things that I need to without having to stop the others.
Okay. Tell me about the things you need. So you're saying it's fast enough, so we'll let you off the hook on that for a moment. But you're saying it's fast enough for what you need. So what are your requirements for your internet connection?
I have to be able to do everything from streaming, gaming, etc.
Okay. So you want to be able to stream on Netflix, play a multiplayer internet game, and then there's other thing called etc.
Sure.
Is that one more thing or many other things?
Could possibly be anything.
Okay. Okay. So now tell me more about this this online multiplayer thing. What kind of internet do you need for that? Do you need good internet for that?
Yes.
Okay. What does it mean for internet to be good for online multiplayer games?
Stable.
Okay. Tell me more about stable.
It doesn't just.
You guys are lucky you get to cheat off his answers here.
It doesn't cut off. It's like
Cut off.
there's
Okay.
a consistent connection.
Okay. Fair enough. Okay, so you're looking for, you don't want drop-offs in your internet. You want there to be consistent service. So I think we can all say that's probably a good measurement of good. Okay, if right off the bat, if our internet, regardless of how good it is, how fast it is, or whatever, when it's on, if it's ever consistently off, if we can't trust when we sit down at the computer whether we're going to have internet now or not, okay, if it's a coin flip, we have bad internet, regardless of how good it is when it's on. Fair enough? Okay, so for online gaming, it needs to be on 99% of the time, right? Consistent. You need to be able to sit down at your computer and trust that you have an internet connection. Fair enough. What else makes it good? As an internet gamer, I'm disturbed that you're not discussing latency at all.
I don't have latency issues.
Okay, what does that mean?
It means that not only is the connection consistent, the data that's being sent in and out is complete and not broken.
Okay. So latency is really a measurement of speed, but not to be confused with bandwidth. So from a bandwidth perspective, do you need a 50 megabit per second connection to play League of Legends? Okay. Could you play League of Legends on a 3 megabit per second connection?
Yeah.
Okay. Easily. Could you play League of Legends? I mean, there's going to be a point where there's at some point
where that stops.
Yeah, but I bet you could play League of Legends on a 768 kilobit per second connection.
Maybe.
The data that they're sending back and forth is very small. It's not big data, but that data needs to move from point A to point B fast. So there's this idea of latency, the amount of time it takes stuff to leave his computer and get to their computer and come back.
My ping is low.
Ping. Yeah, ping, latency, those are measured, those are synonyms. We're talking about the same thing. All right. The round trip time of how long it takes you to communicate with that service. I don't care how fast your internet is in terms of maximum download speed. If you have crappy ping, if you have high latency, you're going to have bad online gaming experience. Okay, so if your ping is like 3,000, okay, that's a 3-second delay. Okay, so a 3-second, so 3,000 milliseconds. So that's a 3-second delay. You make a move with the keyboard or whatever, and 3 seconds later it happens. Okay. You will look like I look at full speed in a first-person shooter.
RTS, you're probably better at first-person shooter.
Oh no.
You're better at StarCraft than you are a first-person shooter.
Yeah. Yeah.
He can't play.
There's, I mean, between for my tremors, I can't keep up very well, and it's just too much stuff. When I was younger, I could do it, but there at some point, it's weird. Like you hear people say it, but age sneaks up on you, and at some point, you are less capable. What's weird, I'm still good at WoW. Like I can play World of Warcraft.
You bought it.
I do, but I can play it. I can actually play it at a high level. So I'm good at World of Warcraft. I'm not like a noob at playing it. I'm good at that game, but I'm a complete noob at first-person shooters. Like I rely on my teammates to kill me so I get new ammo. Okay, because there's like so much stuff going on that everything's moving too quick. So like in World of Warcraft, I'm not very good at PvP. It's like too fast-paced for me. Yeah, Call of Duty, I'd be dead.
I've been playing WoW since like pre.
No, fair. So, but the point I'm making is that so getting back to the joke was a 3-second delay or a 3,000 millisecond ping for somebody who's good at one of these games. Your MOBAs, League of Legends, or something like that would be equivalent to me at real time playing a first person shooter. You're useless. You might as well not be on a team. All right, so so the punchline is ping is another measurement. Latency is another measurement. And if you're a real-time gamer, online gamer, that latency becomes very important. And different games have different kind of latency requirements. So probably our first-person shooters have the highest or most stringent latency requirements. Those need to be as close to absolute real time as possible. When you go down from there, you probably get to something like your League of Legends type games. Those probably are a close-ish second, but they're a little bit less twitchy based. And then you have your real-time strategies are probably a kind of a close third. And then you have your MMOs like WoW, which would be a fourth, but there's more wiggle room there. So unless you're doing real PvP type stuff, if you're just doing player versus environment type stuff in a game like that, if you have 0.6 second ping or something like that, you're probably not really going to notice a delay. Most people have ping significantly faster than that. So there's more wiggle room there. But if you have like, if we're back in the days when somebody was trying to play over one of like the cell phone hotspot or something, which are fast now. You can get pretty good online gaming with LTE today. But if you were trying to do that over like a CDMA connection for like a Verizon, let's say 5 years ago, I mean, your ping might be 14,000.
You might as well be playing Druid as a healer.
True story. Do you play any of these online games?
League.
Oh, you play League of Legends? Yeah, he's big in a league. I don't have time to play the games anymore, so I run robots to play them for me.
You can't really bot League. Well, he's good at jungling.
That's a whole nother backstory.
I don't think he knows what gank means.
I know what gank means. Gank means like you go up behind somebody and catch them off guard, just take them out.
Sure, it's close enough.
Yeah, that's what it is, right?
Yeah.
It's like the modern day pwn noobs.
Yeah.
See?
Sure.
Nailed it. Yeah, I mean, isn't that the thing? Somebody would be coming by and you just all of a sudden come out of the woods and they never even saw it coming. It's like ganking somebody, right?
They think that they got your teammate and you come in behind.
Yeah, so I got it.
Yeah.
See?
I didn't say you were wrong.
Chill. So.
The correct term now is dope.
Oh, is it? Is that really? And that made a comeback?
Depends on who you talk to.
Dope was like that was from years ago. Some of these things are coming back. Is that it?
It depends on who you talk to.
Tell me when the big, tall, fuzzy socks come back.
Wear them anyway.
All right, so you've argued that good means certainly for gaming, latency is probably your highest priority, even though you didn't even mention it until you were prompted. but that's probably your highest priority. Because that's going to bug you the most. If you have to wait an extra 7 seconds for your Netflix movie to buffer, your life's going to go on, right? You know, as long as after that 7 seconds you can watch the whole movie. But if your real-time gaming becomes less real-time, that's a problem. All right, so that's a high priority for you. Okay, so you said you have crappy internet. Explain, based on what we've just learned from this conversation. Why would you say your internet's crappy? Yeah, no, look at it, yeah. Because remember, he said his internet's at least okay, then I convinced him into good.
If one person is on their computer looking something up on Google, someone else on another computer can't watch YouTube on more than 240 at the same
Okay.
time.
All right, so is that an example of a latency problem or a bandwidth problem? Bandwidth problem. Okay, so you have a maximum bandwidth that doesn't live up to what your requirements are for the home. Okay, fair enough.
And also, if you're playing League and someone so much as opens their browser to load the home page,
All is
your ping
lost.
jumps to 1400.
Oh, okay, and so I take it you're not very good at. Are you not very good at League?
Everybody has to disconnect their phones from the Wi-Fi, shut off your laptop. Like only the computers that are actively playing League are connected to the internet.
Playing League at his house is like DEFCON 4. Like, everyone's shut down. We're getting in.
So then you must be good at it. You just have to like micromanage the situation.
And when all my siblings were home for the summer, it was impossible. So,
Is that your parents' house?
So why don't you get better internet?
because my dad can look up his Tigers updates.
That's all that's important.
Yeah,
I mean, can't you like fund it some with the sandwich artist stuff?
we might jump on.
I used to do that. My parents' internet was horrible. I'd be like, look, I will give you money.
He doesn't want to pay more than $35 a month.
$35 a month, you should be able to get reasonable internet.
Yeah. Like,
Time Warner's your provider,
Yeah.
but you're in Port Washington.
Yeah. It used to be that AT&T like did not offer anything to even think about.
Do you like live in the lake?
No.
That's surprising.
Yeah,
Oh.
we're gonna do something about it.
I mean, at the very least, you should have them come out because something sounds like it's wrong with your internet. I don't think your package is too slow. If you're paying $35 a month for internet, you likely have like 30 megabit per second internet. I mean, it probably is not crappy internet on paper, but something's not right with your internet.
Right.
that's not. All right, so you have a bandwidth issue, potentially a latency issue, but it's realistically probably a bandwidth issue just to begin with, since multiple devices seem to slow everything down.
Yeah.
Okay. Alex, why is your internet good for you?
Probably I have 3 designs
Okay, so you really have 3 devices sharing the bandwidth at any single point in time. Okay, and okay, and so you might, if you're watching Netflix, are you also like playing a game on the computer, or are you pretty much doing one thing at a time?
No, I
Do both, okay. And everything you play any games?
no, because sometimes I end up working and watching movies at the same time.
Okay. So realistically speaking, since you're not playing online games, latency is probably a lower priority for you. So
He can communicate to the fatherland, which is the point.
well, so the punchline is let's say you lived out in the booties. Let's say you lived in the middle of the country, and you couldn't get cable modem, or you couldn't get DSLs. Like my brother. My brother lives out in the middle of nowhere. He's in Illinois, but just it's a 15-minute drive to pavement. Okay.
You don't go there a lot for obvious reasons.
No, yeah, he lives out in the middle of nowhere, and Yeah, nowhere asks him for directions. So in any case, he could get satellite-based internet out there. And that's kind of improved a lot over the years. So, if you go to like a HughesNet or something like that, where the satellite kind of looks like DirecTV or Dish Network, looks kind of like that type of thing. And you can get download speeds of, I don't even know what the maximum speed is today, but, you could probably get, 8 or 10 megabits per second download speed over a satellite now. But your real problem is going to be ping latency. So that's become significantly better now than it used to be. If you were trying to play an online game over a satellite-based internet, you probably would have had at best 5,000 ping, so 5-second delay, something like that. That would be considered good.
I just love how Usenet uses the same exact commercial to advertise their service for the last 10 years.
Well, they have a very small market that they're marketing to. Their customers are not looking for cable modems or DSL. Okay, their customers have well water.
Well, the commercials are just like,
And
we
outhouses.
can get this photo up here faster than okay.
Their customers have well water and outhouses.
While you're going
Nothing
outside,
they have has progressed in those 10 years. So why does it stay updated?
they don't know the others exist.
It was like add to the Jeff Foxworthy jokes, but it's not. It wouldn't be a hillbilly. Like if you live out in the boonies, you're not necessarily a hillbilly.
Isn't you're a redneck?
Yeah, his is you might be a redneck, right? But like if you have to shovel, if you have to shovel your snow so that you could use the bathroom. I don't know what they would those. What would somebody who lives out in the middle? Those just survivalists.
Poor people?
No, my brother lives out there by choice.
Hicks. People who just don't know the rest
it really
exists.
just depends on the person.
Well, everything in Indiana is like that.
No, that's just natural. That's all the Amish.
It's not the Amish. All right.
The
So
Amish-
you said you have bad internet at home. Okay. So tell me about your internet at
I
home.
think it's more of a bandwidth issue.
Okay.
When no one's home but me, I can get good internet.
Okay.
But other than that, I'm
Is
screwed.
it who's your provider? Is it DSL or cable?
I think we have Dish Network as our, and then AT&T I think is our internet, so it'd be cable.
Okay. Well, AT&T would be DSL.
Yeah, so I mean,
we,
I don't even know. I don't pay
we get our point-to-point wireless connection from Ezekiel down the street. The guy's done some amazing stuff with shovels as reflectors.
You get him. He's doing like the not Jay Leno, the guy before him.
Johnny Carson?
Yeah. The Amish get better internet. That's how bad it is.
It gets bad, well, especially since I have my laptop, the PlayStation, my little brother has a PlayStation. My dad just gets on the iPad, watching Netflix.
Okay.
It's stupid.
And you guys are sharing, do you even know what speed you have?
No, I have no idea. I don't even pay attention. Well, that's why I don't try to play games when I'm at home.
He doesn't like to go home.
Yeah, when I'm home, I'm too busy to even game.
And you said you have bad internet?
Yep.
All right, so where's this internet at?
I'm in the same boat as Tim. I have Time Warner.
Okay.
So if there are other people there, I really can't do much at all. So
And which part of town is this in?
Germantown.
You could what? Germantown's in the middle of stuff.
Yeah. So what do you know? What speed internet you have?
I believe it's 15 megabit.
15. So one of their cheaper plans, but 15 is
Yeah, I
fine.
think it's like that.
That's not. That should be fine.
Or
Are you like it's an apartment complex?
And see what they're doing.
I don't
So
know.
is this in an apartment complex?
Yeah.
Is it shared with other people in the apartment?
I don't think so.
You're paying the bill.
It should be.
It should be dedicated to you guys.
Yeah.
Okay.
This is what you do when you go home. You change your Wi-Fi password and you switch Wi-Fi channels.
Yes, this sounds like something's wrong there too.
Because I actually had that in my apartment building. It's not shared,
Mhm.
but
It seems like it is.
The connection itself to the rest is shared through the building. So hop on and do a different Wi-Fi channel in your settings and see what happens. Because we had that, and there were like 50 people on channel 1.
Yeah.
So we just switched off that, and we were screaming.
Yeah, because my roommates will be gone, and it'll still be off and on.
Huh. Because I'm on Time Warner in Grafton, and when I'm patching WoW or something, it downloads So I just came back to the game the other day, so I had to download like huge patches. And it was downloading at like 17 megabytes per second, and I was watching Netflix. And I was botting Pokemon Go and Hearthstone. What's up? No.
Really?
Yeah, I hacked this bot. Ended up couldn't keep up with the Joneses.
Really? Someone passed them up?
Oh, but then they started banning everybody. It was terrible.
Yeah.
I'm on like my 4th Pokemon Go account.
For the after week 2 or something.
Yeah, he had
fairly recently. He had the fastest bot on the net.
Really?
He had like a huge forum. He had
Were people paying for it?
No, he
No,
could have
like,
charged for it easily.
people were just calling his GitHub. His GitHub project was like trending for like 2 weeks.
Yeah, it really was.
He had a Discord channel for it that had like 40,000 people on it.
Yeah, but so I stopped using it.
So what was that for Android only?
No, it's PC.
It was on your PC and it hooked into it.
Yeah, it just uses the Pokemon API. So
Or like the Google API.
yeah, like my current Pokemon Go account has never been logged in on a device.
He had the he caught the region specific stuff from Asia.
Oh yeah, I was like farming stuff in the Olympic Village. Yeah, like the
I had a joke with an iPad, so I could click and go wherever I wanted. So I'd be like playing the game, and, like tapping on the screen where I wanted to go, and it would go wherever.
Same thing, essentially.
well, not for me.
You had a bot that just did that for you.
So we've been here for 3.5 hours now.
Yeah.
I'm playing Pokemon Go right now,
Would it catch anything or no?
and now, still now.
Would it do gyms?
It doesn't do gyms. I wouldn't do gyms anyways because I think that breaks the economy of the game. I mean, if I'm gonna bot a game, so this is more of an ethics thing. I won't, like World of Warcraft, for example. I won't put anything on the auction house because that's not for me to earn stuff that I couldn't have earned otherwise, and then make it worse for other people by breaking the auction house economy. Because I got so much leather that I got leather that couldn't have been farmed by a human being. Because my guy spent 6 days straight farming leather. I just inundate the auction house with it. You break the economy of that server, and that's not fair to other players. So if I want to farm gold, I just do an instance that drops raw gold, and I just get my guy gold.
Do they have bots that do that at the auction house?
Well, what do you mean?
Like, do they have bots that sell crap on the auction house?
They do, but I mean, most people who want to sell on the auction house just do it manually because there's some plugins, like legal plugins that help you manage the auction house. But the point is that I mean, you're hurting the game that you like playing. I mean, I think a reasonable reason to bot. I mean, I'd be fine playing a server that was only bots. I mean, I like the content, but I've played all the content multiple times, so I don't have time to sit there and just grind stuff. I want to play the new content or do the stuff I'm currently working on, and not have to waste 20 hours doing stuff that's just time. You don't want to make the experience worse for other players.
It makes me think though, because like people come out with these like articles and stuff talking about like how like World of Warcraft and the EVE Online like have been teaching people kind of how economies work and that sort of because
sure.
they have those inner economies, and if bots can access that, there's an inaccuracy to that.
Well, but I think that's where the bans come in. I mean, I think your highest chance of getting banned in World of Warcraft, because the bots are pretty refined now. I mean, they've been around for a while. Your highest chance is if your behavior looks like a bot. That is, you're selling way more stuff than a human being could have done. So you're actually hurting the economy.
Right. So they can notice that.
Same thing would be true for like Pokemon Go. I think if you're, because my interest in that is basically filling the Pokedex, catching all of the guys and just saying I did. But, when my first account got banned, I was level 35. Nobody around here was 35. So what, I'm going to go throw one of my, 3,800 CP guys on a, the school's gym, and nobody's going to be able to kill it.
800.
Yeah, you're not going to be able to kill it. So, I think that breaks the game for other people. So
How are they detecting if you're botting?
For them, it's got to be API calls because the bots are just obscene. The bots don't even try not to get caught.
Oh yeah, hacks.
The bot that I use now, it does sniping, so it doesn't even stay in the same GPS location.
No, they started doing stuff with that.
Yeah.
Earlier.
Yeah, oh yeah. But I'm just saying that we don't even try to avoid it. So it looks at my Pokedex, and then it looks at the entire planet of currently spawned Pokemon. And if there's something that's spawned anywhere in the world that's not on my Pokedex, it snipes it. It jumps to that location, gets it, and jumps back.
So how have you not gotten them all now? Besides,
I have multiple times. Yeah, I got like on my first account I had like 400 and some odd Dragonites. Like
Did you get all the EVs? All the three separate ones?
Yeah, you can find those in the wild.
I know. Well, no, there are 3 different ways to do it.
Yeah.
Names.
Yeah,
I had maxed out of those, so
Okay.
IV 100. Yeah. I was cheating.
I realized that.
I had everything. Yeah, you know how like the obnoxious thing is the Magikarps, where you have to get 400 of those things in order to evolve it. Okay, I probably had like 200 or 300 evolved guys. The dragon guy. Oh, it was completely obscene. Yeah,
If anything,
I've never been to a gym on the account, on any of my accounts.
You just avoid gyms.
Yeah, in general, it's more of a life choice. All right. Let's keep trucking here. Now that we've dealt with the ethics part of the class, we just discussed ethical cheating. If you're gonna cheat at a game, don't ruin the experience for other people who don't want to cheat. Who don't want to cheat. All right. So let's see. So we had your internet's Time Warner bad. We got everybody now, right?
Yeah.
Okay. So
why is your internet good?
why is my internet good? Well, I think I kind of cover both bases, bandwidth and latency. So, I have Time Warner. I have a good connection. So my average ping is low milliseconds. So 10 milliseconds, 11 milliseconds is kind of your average ping. So low, it's fine, and my bandwidth is ridiculous. So I rarely have an issue. I'm usually running 3 simultaneous bots, maybe streaming Netflix on 2 different TVs. So plenty of stuff. And then my wife is doing her photo album stuff from our trip to Israel right now. She's putting zillions of images, and they're making some sort of professional photo album. It's above my pay grade. I don't know. I just paid for the trip.
Well, you went.
Yeah, I went. Yeah, it's true.
Went, almost got killed a few times.
It was safer than it should have been.
The religious zealots.
Yeah, but that was.
Wife almost got killed.
Yeah, that's true.
What?
Yeah, and then King David's tomb. They separate the men and the women. So, and you have all sorts of different religious groups over there that are all kind of Christian groups, but they all have very different views on what's appropriate and stuff. So on our side, of the guy's side, and it's really weird. So if you walk into a church and you're wearing a hat, usually you would take the hat off, right? That's kind of your go-to show respect, take the hat off in a church because it's disrespectful or something like that. So we go into King David's tomb, and I take my hat off, like I had been doing at every other church. Take your hat off, so nobody yells at you. Fine. Well, apparently in King David's tomb, you have to put the hat on. You got to cover your head. They have yarmulkes and stuff in there, but it wasn't clear to us. But on the guy's side, they were cool about it. The guy pointed to me and said, pointed to his head and said, so I put my hat back on. No issue. It was friendly. On the women's side, there was an issue. Apparently, somebody from our group was showing too much shoulder. I guess they didn't have sleeves. They just had like the tank top type thing. And some nun on that side flipped out. And I think our tour guide, also a lady over on that side, basically got in a fight with her. They were like in a shouting match. And they ended up bringing in the Israeli police to haul this nun away. I think ultimately it came down to an elitist thing that our tour guide did, because American tour groups over there are treated like royalty, is the impression I've gotten. So like as you're going through Israel, there's all sorts of checkpoints because you move in and out of Israeli state and Palestinian state. Well, both of those sides are friendly with Americans. So when your bus goes through, somebody with an assault rifle comes onto the bus, whether it's an Israeli or a Palestinian. And our bus driver would just say, these are Americans, and he would just wave us through. But other groups would have to get visas out and cavity searches and who knows what else. So the second our tour guide told the Israeli police that an American tour group was having a problem in there, the Israeli police just right into this thing, went right to the women's side. It was male police. And just drug this nun out like it was nothing. I thought it was pretty awesome.
What was it, the Holies bird poop incident?
Oh yeah. So we were at the wailing wall, and so I had my hand up on the wall, and a bird pooped on my arm. I have pictures of this. So now you're like in a kind of very religious sensitive place, and you're kind of at the most religious sensitive place there. You can't like wipe a bird poop from your arm onto the wall. Something bad might happen. Like seriously over there, somebody might do something to you if you do something like that. So I'm like, okay, I gotta walk around with bird poop. I'm like, okay. Well now, so we're up. So right next to the wailing wall, you have this thing called the Holy of Holies that only Jews are allowed to enter. So I was born Jewish. I got the nose, you can see there. So I'm Lutheran now, but so I have the credentials. So I couldn't go over there and not go in. So I went in there. So I'm walking in the Holy with bird poop in my arm, and I'm like thinking I'm gonna wipe it with like a yarmulke or something like that. I ended up just keeping it, and had my wife help clean me up when I got back to the group, because I was the only one allowed to go into this like the sacred place that had a whole bunch of like crazy looking Jewish people in there, like doing all like bowing and praying and so I walked through with bird poop. Was that participating? Yeah, I don't know. These guys, they get, they're like prostrate on the ground, like really low, like bowing at the wall and stuff. Like positions I can't get into. So, that's above my pay grade too. But very interesting experience. But I was told it's actually good luck to have a bird poop on you while you're at the wall. And they seemed like they were being serious when they said that. Like didn't seem like it was the first time it's happened, is the impression I got. All right, so getting back. All right, so when we talk about what good means, whether we're dealing with internet speed, whether we're dealing with transfer speed between hard drives, whether we're talking about CD burners, whatever it is, good can mean different things depending on the application. Okay? So one thing we want to refrain from is our human sense of immediately jumping too fast is better. Okay? Because sometimes we just talked about, internet is a good one for us because we, especially as younger people, we're able to think about the different types of things we use our internet for, and good means different things for different types of things. So something that Tim said was stable. that his connection is reliably on. Okay. Another thing is latency. You want it to be reliably on and quick turnaround time. If you're an online gamer, that's far, far more important than bandwidth. You'd rather have reliable and fast latency and give up some bandwidth than give up any of those other two for online gaming, because online gaming is not a bandwidth intensive endeavor. That's why the installs are so big. That's why a game is a 25 gig install, because all those graphics and all the big things are all local on your machine. And what you're sending back and forth is little tiny data package that says, my dude is now here, now he's 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 here. And if that has big delays in it, you have a problem. All right, so good means a whole bunch of different stuff. All right, so we talked about CPU versus GPU, and really this discussion deals with general purpose versus domain specific. GPUs are really good at doing math. All right, CPUs are good at doing general things. All right, so let me kind of go here. Actually, let's keep the discussion right here. This would be a good one, because I want to, because of where we're going to finish off today, I need to come up with, have our paper topic. So I think this will take us to a decent place. So let's kind of go back and let's talk a little bit more about CPUs. So when we think about a CPU, we're really thinking about this guy as a collection of circuits. All right, so now we think about what's a circuit. And we, Curcio and I had this discussion earlier in the other class, but we want to draw some parallels between writing software in Python or Java, something like that, and creating a digital circuit with wires and stuff. These things are remarkably similar, even though they seem dissimilar. Both of those, I think you could fairly classify as a program. Okay, the way I like to think about software is if you've ever seen like I don't know if it's The Price is Right or Let's Make a Deal, the one that has the Plinko.
Yeah,
Price is Right. Okay, so you drop the coin in right in the top, and it starts bouncing around and ends up in one of the output columns, right? After it took all sorts of different twists and turns as it went. So a software product is kind of like that. Okay, so the idea is that you have an input or some number of inputs, and based on a whole bunch of questions, a bunch of Boolean logic, if this is true, go here. If this is true, go here. If this is true, go here. It's going to bounce around, and ultimately you get a result. Okay, and that result is the summation of all the decisions that were made leading up to that point. Make sense? Now, when we deal with that at the software level, it's convenient. And I'm going to come back to that here in a second. But now let's think about it at the hardware level. If we are creating a digital circuit for accomplishing something, all right, so maybe we have a switch here and we have a light here, all right, and in between is the digital circuit. So when we hit the switch, electricity flows, and depending on the current state of the switch, that electricity either gets blocked from getting to the light or doesn't get blocked from getting to the light. So the light either lights up or it doesn't. All right, so that's a simple digital circuit. So depending on the state of the button, the switch, whatever, that's going to depend on whether this guy gets lit up. Now, if we make this more complex and we say we have a series of switches, and under certain circumstances, if the first two switches are on and the next two are off, then these two lights light up. Different configurations of these switches make other lights come on or off, that type of stuff. So in between the switches and your lights, you have all of these wires that are flowing through decision-making gates, AND gates, OR gates. Effectively the same thing as an if statement in Java. You're asking a question. If it's true, electricity gets through. If it's false, electricity doesn't. Okay? So we're really solving programming type problems with digital circuits. Now, when I said that software is convenient, what I mean is if you're writing a Java program or a Python program or whatever, and you've introduced a small little logic error into it, What's the fix? You backspace a couple times, you change it, you recompile, and you run it. Okay? No harm, no foul. Life goes on. It's easy to fix. Now, if you've built a, let's call it a prototype digital circuit, so you've used actual wires, actual and and OR gates with solder. Okay, you solder all this stuff together onto a breadboard. And if you, how many of you have heard of a breadboard before? Okay, 3.5 of you.
That's full.
Oh, you're just short, so I didn't. Let's probably bring it up. So something like this would be considered a solderless breadboard. So inside of each of these little dots, there's a metallic filler in there, and if you stick a wire in there, it kind of catches. It's got like it almost pinches in a little bit. So that'll provide power to it. So that's considered a solderless breadboard. Let's see if they have a. Yeah, here we go. These would be breadboards that require solder. So notice they're thinner and there's metallic contacts on all the little things because that's where the solder goes. It creates a contact between whatever wire you put here and the circle thing. So this is actually a good example for what I'm talking about here. So let's say you build a program in hardware on this breadboard. So you've gotten the solder out, and if you're like me, and so I have tremors in my left hand, so I'm a little dangerous with a solder gun. is what it comes down to. So basically things are shaking all over the place. If you make a little bug, you've introduced a bug into your digital circuit, how do you fix it? Well, on the software side of things, you backspace, you change it, you recompile, everything's good. Now you got to start melting off solder that was already there, hoping you didn't, screw up some other spot on there by having a little solder connect something that you didn't mean to connect. You might have to start all over. Solderless breadboards make prototyping a little bit easier because now you're at least not, dealing with molten metal that might have spilled all over the place, but it's still a headache. So if you have all these wires, so if we kind of come back to one of these pictures that shows some breadboard stuff. Yeah, here we go. This probably shows some stuff. Good enough. So you have all these different wires that are coming here. This actually looks more stable than most would actually end up being. But, when you find a bug in there and you move this wire to here, you risk possibly knocking another wire out, or a wire gets a little loose so the contact isn't quite as good as it should be. Stuff like that. So there's a lot of variance that goes into these kind of digital prototypes, these hardware-based prototypes. So you kind of have to get it right the first time. All right. So kind of think back into the very early days of digital hardware, and think about the nature of kind of evolving our digital hardware. Things that we sit down, if we want to write software today, we can fix our bugs very quickly. The amount of time it would have taken to fix a broken prototype, and when you think about writing a piece of software today, how many times do you go back and fix bugs? For even a relatively simple program, you're fixing quite a few bugs, right? And each one of those bug fixes is, let's say, 5 minutes for kind of a intermediate programmer or something like that. So let's take that equivalent person in the hardware world. That 5 minutes is probably more like 30 minutes to undo a bug. And the problem is that when you fix it, you think you fixed it, you may not have actually fixed it the way you think you fixed it. So you might end up having a solution that's now correct in terms of what you tried to do, but incorrect in terms of what you actually did because you dripped a little solder over the wrong contact or something like that. It's kind of interesting to see that we've actually gotten where we've gotten today with hardware. And a lot of that comes from software. our modern day way of dealing with, building prototypes. I mean, so this is kind of our prototype building type thing here. If you're just trying to slop something together as a proof of concept. Whenever you're going to want to build something for real, like a testing prototype, or you want to mass produce something, you start getting into this idea of something called very large scale integration, where you're using effectively printers that print circuit boards. Okay, they print these contacts on the circuit boards, so you don't have these wires going all over the place. Well, before you want to invest in a multi-million-dollar machine that knows how to print circuit boards, you probably want to kind of test your circuits. Now, we can test our circuits this way, or we also have simulation software today that allows you to effectively build digital circuits in software, test it in software, and then ultimately deploy it to hardware using a circuit printer. That makes sense? So software has actually evolved our hardware creation. It's allowed us to create better hardware more quickly, more cheaply, because the number of iterations went way, way down. We didn't have to build it once, then break it, then build it again, then break it, then build it again, over and over and over again. Okay, so we talk about, let's see where I want to go with this one. Okay, so Curcio's not allowed to answer this one because he already had this discussion earlier today. So, how many of you have heard of the word firmware? Okay, what is firmware? So one of the things, and most of you already know this about me, but being your first time, I'm a advocate, I guess, of vocabulary. So there are so many buzzwords that float around, and smart people like to make themselves sound better by using big words that mean simple things. Okay, the Java word I like is polymorphism. Okay, so scary sounding word that means something simple. So firmware kind of sounds like software, right? But instead of the word soft, we've thrown the word firm in there. But it's not hard. It's not hardware. Hardware is physically rigid, right? Software is physically not even there. So what's firmware? Somewhere in the middle? Huh? Okay. Driver would be fully software. But I think, again, you're not as off as the words that came out are closer than they should be, but I don't think you know that. Well, fine. So, driver it's software. I mean, driver is 100% software. So what's firmware? Where does firmware exist? Based on your experience of dealing with hardware and things like that, when have you run into a situation where you had to deal with firmware? When have you ever had to upgrade firmware or downloaded new firmware? Give me some examples. Not Curcio, though.
Is it like one step farther towards the hardware side than a driver would be? So it's not connecting the software to the hardware. It's
You can't just give me an example of when you've ever had to upgrade firmware? Really?
not that I remember.
Yeah. So, when your PlayStation has a software update, sometimes it'll say it needs to update the firmware. Probably where it's common would be on like routers, things like that, where you update the firmware and it says there's a firmware update for this. Please don't turn the device off while this is being applied. It downloads something off the internet, but it installs it in the router. And the router is, from our perspective, a piece of hardware. So, do I have my programmable microcontroller thing in here? No, let's throw that in here. Is it on one of those?
If you go down, isn't it on that? Or no? You go up to firmware, down one slide there.
That's the assembly language is the next one.
No, up to. Or are you talking about like an actual slide about it?
Yeah, about the programmable. I'll just write it again. Worst that happens is there twice. It doesn't matter. Did I spell programmable right?
That's it.
Nailed it. All right, so programmable microcontrollers. How many of you have heard of this at some level? Okay. How many of you have heard of an Arduino? So this guy. Arduino. So this guy's going to kind of look like our breadboard that we were just looking at here a few minutes ago. Let's bring this picture up. So here's kind of the breadboard pieces of it. These guys here. So things where it looks like you could stick wires, they'll probably stay in there, that kind of thing. All right. But this is called a programmable microcontroller. Now, when we hear the word program, we think software, right? Even though I've kind of made this parallel saying that our software programs and our hardware circuits they're the same thing, just made out of different materials, right? I think that's an important parallel to draw because I don't want to necessarily think of yourself as a computer programmer, but you don't know what hardware is. You might not sit around and do things with a soldering iron and stuff like that, but it's still the same kind of logic that you're working with, right? So these guys here look like our breadboard stuff, right? All right, but we don't have a whole big wall of breadboard stuff between here. This guy's called a programmable microcontroller. So this is an Arduino. This is a USB port. So you plug this guy into your computer, and there's a text editor that's associated with this, where you can write your program. It's a C++ variant language that has the Arduino syntax in it. So you write a C++ program that replaces all of these digital circuits that you might have here in the middle. So when you think about that breadboard, it had a whole lot more holes in it than this for putting AND gates and OR gates and all sorts of other digital logic stuff here in the middle. We've taken all of that out. And now we've said, oh, we're just going to store one little program right here. So this guy right here is going to store whatever program that you uploaded to the Arduino from your text editor on the computer. And then when you say go, this is the brains of this guy. He's going to run, actually I have this backwards. This is where it's stored, this is the brains. So this will get stored, so the processor, the very domain-specific processor that only knows how to run Arduino code, it's going to launch the program stored here, run it. These are the inputs, these are the outputs. Is that the guess right? No. Oh, these are analog in, yeah. Analog in, these are the outputs. Okay, so these are your various inputs coming in. And based on these inputs, it's going to run through this program and output power to whatever these wires go to. Okay? So rather than having to do all that digital circuit stuff with soldering irons and getting AND gates and OR gates and things like that, we can use our common software programming logic to write if statements, write loops, all sorts of things like that. But ultimately, the output of our program is experienced in hardware. Make sense? So this guy's a hybrid. So it allows us to pull off hardware things so we can build patterns and Christmas lights and stuff like that if we wanted to, so we can do various projects like that. It allows us to have an actual physical device that we created, but that was controlled by software that we wrote. Make sense? So this is hardware done the easy way, the convenient way, because we can write software. We don't have to unsolder stuff to fix a bug. We just go in and change our software a little bit, re-upload it to the Arduino and say go. Okay? So the only things that we would even change is our inputs and our outputs. Where do these things lead? Okay? And if you don't have enough inputs, you don't have enough outputs, you can start stacking multiple Arduinos together, or you can get larger programmable microcontrollers. So Arduino is kind of like a kit thing, so they're cheap. They're like $30 or something like that. So you can do all sorts of different stuff with this type of thing, and you can attach various sensors to it. I knew a guy who kind of built a project that had like accelerometers and stuff all coming into it. He did some sort of running thing that, kind of like basically what a Fitbit does without being a Fitbit. He just built it. Another buddy of mine took an Arduino and built a fish feeder. So like the true geek. So you could probably go on to Amazon. You can get like a fish feeder type thing where you can put the flakes in there and say how often you want it to go in there, and it's probably what, like $20 maybe. Okay.
So we spent 40 on it rather.
I bet you spent more than 40. Yeah, because he built this thing. So it was with an Arduino, a Raspberry Pi, because he can control it remotely, and he 3D printed all like the wheels and stuff for dropping the flakes in. So total geek project, right? At 4 times the cost of what he could have just bought the thing for, but he had fun doing it. So I guess that's kind of the punchline with it. All right, so this idea of a programmable microcontroller is kind of our modern cool kid thing that I guess a lot of people are getting into as we're starting to think about, everybody has an app idea. If you think about like an iPhone app or something like that. So, ideas are a dime a dozen. It seems like more often now, people are trying to move away from true software solutions to kind of hardware hybrid solutions. We've seen it when we've gone to some of these hackathons. A lot of the projects that have done quite well at these programming competitions are hardware-based projects because they're kind of rare. People don't typically do too much with the hardware side of things because it's not convenient to typically, typically if you go to a programming competition, you don't see people pulling out soldering irons. Right? It's not a thing. But now you have this convenience where you can really build things that exist in the physical world that do something, but still mostly through software. So kind of an interesting thing. Now, kind of staying with our topic that we've been talking about most of the night, is a programmable microcontroller like this better than a solderable breadboard with wires and all that stuff?
Not necessarily.
Okay. So, okay. All right. Good. Yeah. So that's a good question. What does better mean? When you think about hardware, our natural gut feeling is it has to be fast, right? I mean, when we think of something as being a physical computing part, we assume no slowdown, right? But now, in this particular case, it's effectively the same argument as a virtual machine. There is interpretation that is happening between our inputs and our outputs. All right, that interpretation is happening at our program level right here. So with that in mind, this guy will be slower than a equivalent fully soldered hardware circuit. Correct? Okay. Is that a problem?
Am I mass producing those, or am I testing something to see what I would?
Even if you were mass producing, I mean, it really matters on what the problem it's solving is, right?
If you're testing the setup, then it would be better than having the physical circuits, because if you make a mistake, then you fry your circuit. You have to
Oh, certainly. Yeah, so we've already, you're right. We've already kind of moved past this idea. Clearly, this is more convenient. Yeah, any way you cut it, this is more convenient. That argument's out the window, right? This is more convenient than melting off solder. But is this better anyways? Even though it's slower, is slower okay? Just to kind of maybe expedite things here, we can say many times it might be, right? And especially when we're dealing with this, because how fast is electricity? Close to the speed of light. You know, there's going to be some level of resistance from the wires and stuff like that, but fast. The example I used earlier is how many of you can tell the difference, I used it in the class earlier today, between the speed of light and half of the speed of light. How many of us could perceive that difference? Or the speed of light and 100th of the speed of light. Human beings can't perceive that. That's really fast, right? So for most things, this is more than adequate because this is still going to be faster than software. And we actually have a real product. You know, it's not something that we have to experience through a keyboard and mouse. Now we have something that physically lives in the real world. All right, so I'll put up.
Would there actually be a difference though between, say, that and like just a breadboard in terms of like certain amounts of control you can have over certain things?
I don't
You like in terms of like what you can affect, whereas like with a breadboard you have all of the parts at your disposal.
Yeah, that's a true statement. You're limited to whatever Arduino's API supports in terms of what physical digital circuits can we fake in hardware.
Like between, say, like Swift and Objective-C gives you more control.
But the reality is that you probably, since you could write your own functions and you could probably mimic anything that you could do with hardware with a sensor and a function. So it probably really isn't that limiting. But I mean, it's a reasonable question you ask. So in any case, so 2 homework assignments for next class. I'll put up the paper topic when I get home later tonight. But the paper topic is going to be dealing with something called a application-specific integrated circuit. All right, so we've been talking about integrated circuits today, so we're going to specifically look into these things as they relate to Bitcoins. So kind of a cryptocurrency related to computer science and circuits specifically made for those and kind of how that's evolved, how we've gone from doing that with CPUs to GPUs to now specialty circuits that are made specifically for mining Bitcoins.
You still doing that?
Well, I haven't been doing that for a while, but it's a very interesting topic to look at, which relates directly to what we just talked about. Kind of that evolution of how these things go from general purpose to domain specific. So I'll put that topic up. And then the other thing is going to be, and this is the similar to what you had in the other class, but this tutorial point thing here for the assembly language, I want you to go through the first 3 steps of this: introduction, environment setup, and basic syntax. And we will have a quiz next class at the beginning on something from these 3 sections.
Can you put up a link?
It's already on.
Oh, okay.
Yep, it's already on there. So in any case,
just touching on that, do we like? So is there anything involving the book for this next?
No.
Okay.
no. I mean, I'm going to assume that you'll all have the book by next Tuesday, but nothing. The book is not going to be required between now and next Tuesday. But it will be required next week. Yeah, it will be required next week. We'll start using the book next week. All right. So I won't put this up as an official homework assignment because I'm really asking you to study some of the stuff here. So you will have a quiz involving these 3 things, and then you'll have a paper involving application-specific integrated circuits. And I'll put the topic up for that specifically. It'll be 2 to 3 pages. Yep. And you could double space it, whatever. Don't go crazy with font. I'm not looking for length. I'm looking for quality, right? All right. Questions, comments, concerns, bribes.
I mean, you go by the public market every day. You want something?